There are 311 million people living in the U.S. 8 out of 10 of those people own a vehicle. A typical light-duty vehicle uses approximately 65 gallons of gas per year to power the AC unit. That's 16 billion gallons of gas consumed per year in the U.S. The AC compressor in your car uses approximately 3 kilowatts of power. But if we modify the AC compressor with a zonal cooling concept, we can decrease the load on the engine by 16%. So if we use this method, we can achieve an increase of 1 mile per gallon in fuel economy per person per year. This constitutes a savings of $6 billion on fuel consumption in the U.S. annually. Have you ever fought with the passenger in your car about the temperature of the cabin? Zonal cooling eliminates this fight. The idea is to cool zones of the car instead of the entire cabin. This same zonal cooling concept can also be applied to cooling an individual worker in a commercial building. In the U.S., there are more than 820,000 commercial buildings spending over $2.9 billion per year on cooling the buildings. This is a problem because the average office worker only utilizes half of the currently cooled space. However, the zonal cooling method cools each individual office when the space is in use. The zonal cooling method is thus effective at providing the same level of comfort to the worker, but uses less energy. So what exactly is a zonal cooling unit? Zonal cooling units are made up of Peltier cooling modules which use electricity to create a temperature difference. Each thermoelectric module is made up of approximately 52 legs. These legs are connected to one another electrically in series and thermally in parallel. When the module is powered, these legs work together to create a temperature difference. These Peltier cooling modules will be created by our company, AMat. AMat is a team of 5 engineers who synthesize the legs that are used to power the module. Altogether, our team has over 72 years of experience in thermoelectrics. Additionally, we have the necessary equipment and systems to achieve accurate and precise measurements on the materials used in these Peltier cooling devices. The Department of Energy is currently invested in the research performed in Dr. Terry Tritt's Complex and Advanced Materials Lab. If the DOE invests in AMat, we know the company will succeed under the guidance of Dr. Terry Tritt, Dr. Jeff Sharp, and the rest of our highly trained team.